Namaskar. Last time this was homework that this is our regular RS flip-flop made up of maybe NOR gates like this. What is the additional part? Additional part is that now the R input is provided through a AND gate and S input is also provided through a AND gate, and gate is the additional input which is common for both these AND gates, and it was expected to prepare a truth table. I had given only the titles of the columns, that is what happens if G has different values, R has different values, S has different values, and you had prepared this table, correct? You had prepared this table, you have done the homework. But now what we will do? We shall prepare the truth table here and then we will compare it with the results you prepared as a homework. Now, when we observe through this circuit, you will observe that if G is 0, that is gate input is 0, then irrespective of R input of RS flip-flop, this is RS flip-flop, R input of RS flip-flop is 0. Similarly, if gate is 0, then irrespective of S, this S input of RS flip-flop is 0, right? And we already know that in case of RS flip-flop, if R and S input are 0, 0, then the output is as it is the previous state. And so, while preparing a truth table, what I will do? If gate is 0, for any combination of RS, that means actually here there are 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. For any combination of this R and S, input to the RS flip-flop will remain 0 and so the output remains as it is. How can I represent this? Here I can represent it as X, and X indicates that it is don't care. That is, it may be 0, may be 1. So it is 0, 0, 0, 1, 1, 0 and 1, 1. In any case, the output remains as it is. And how can I represent it? Remains as it is. I can represent that the nth state will be same as n minus first state, that is previous state, and we are aware about that. Here also we have mentioned that if it is 0, 0, then it remains as it is. We have mentioned that as it is, right? Okay. Now, what about Qn bar? It is Qn minus 1 bar, previous state as it is. So, actually this single row of the truth table includes 4 rows. For 0, 0, 1 row, 0, 1, 1 row, 1, 0, 1 row and 1, 1, 1 row. Therefore, this is equivalent to 4 rows. But suppose gate is 1. Now gate is 1. What is the input to RS flip-flop? It depends on what is the value of R. So now we will have to write with gate is 1 if R is 0 and S is 0. But now I can realize that if gate is 1, role of this gate is just to allow the value of R as a R input to RS flip-flop. What I am calling that, see, the role of gate is just to allow the R input as R input of RS flip-flop and S input as S input of RS flip-flop. Means just it allows, and now gate is 1, so these values remains as it is. They are allowed to appear as a input for RS flip-flop, and so I will have to consider all 4 combinations. Here it is 1, here it is 1 0, here it is 1, here it is 1 1. But once those values appear as an input to RS flip-flop, behavior of RS flip-flop should be same as the RS flip-flop, like that. Okay. Therefore, this block has to behave as a RS flip-flop only. And we know that in case of RS flip-flop, if both the inputs are 0 0, then the output remains as it is. If S is equal to 1, then the flip-flop sets. If R is equal to 1, then the flip-flop resets. Check what I am writing. If S is equal to 1, flip-flop sets means the main output Qn becomes 1. Second one is complementary. If R is equal to 1, flip-flop resets, that means Qn becomes 0 and Qn bar obviously it is 1. And if both are 1 1, here we have observed, if both are 1 1, then these both our outputs are 0 and this is forbidden or illegal or unexpected state. This is unexpected state. And so this is the truth table of this circuit. And now this circuit, which consists of the basic RS flip-flop along with a gate, is known as gated flip-flop. It is gated flip-flop. That means now you may use this R and S for any data. Keeping gate to be 0, there is no effect on the output. Check, here I have mentioned that if gate is 0, irrespective of R and S, the output remains as it is. Now previously we were calling this as a latch. Why? The reason was that, see, here it is latch. We have mentioned that it is latch. What is the reason? If the R and S are 0 0, output remains as it is, it gets locked. So it is latch. But it was not possible to use R and S for some other purpose. Here it is possible. How? If I make the gate to be 0, I can use R and S to latch the data on other flip-flop. I will show you this diagram, circuit diagram. Okay. Now check. This is gated RS flip-flop. So there is gate, there is R input, S input, this is Qn and this is Qn bar. This is one flip-flop. I will write here it is gated RS flip-flop 1 or actually 0. Then suppose this is gated RS flip-flop 1 and one more flip-flop. It may happen that there is a series of flip-flop, gated RS flip-flop 2. And what I will do, I will make all the R inputs common. So here I will combine them together. And this is common input R. Similarly, what I will do, I will combine all S inputs and let this is S input. Okay, let this is S input. Okay, therefore this is S input and this is R input, so that it is in a single field of view of the video. This is R input and this is S input. You will realize that this R input is common for FF0, FF1 and FF2. I will call this as G0. Similarly, this will be the gate of first and this will be the gate of second. Now let me know, this is Qn0, Qn0 bar, this is Qn1, this is Qn2 and obviously other output is complement. Now let me know, Suppose all the gates are 0 0 0. If I change the value of R and S, will there be any change in these outputs? Answer is no. Why? Because gate input of every flip-flop is 0, and we have observed if gate is 0, then for any value of R and S, the output remains as it is, Qn minus 1 bar. Now suppose if gate of 0th flip-flop is 1, therefore suppose now this is 1, but this is 0 and this is 0. Now we can comment that now first 0th flip-flop is active. So the inputs R and S affects the output of 0th flip-flop only. If I make S to be 1 and R to be 0, this gets set. The second flip-flop, that is FF1 and FF2, are unaffected. They will not change their output. What is the reason? Reason is that gate 1 and gate 2 are 0 0. Right? So R and S inputs are common for all these three flip-flops, but now we have disabled these two flip-flops by means of gate 1 and gate 2, and only FF0 is giving response for R and S input because gate 0 is 1. Right? So 1 gets latch here. If I will have to store 0 in this, what I will have to do? I will have to make this 0, make this 1, keep this 0, R to be 1, S to be 0. So you will observe that now this S is equal to 0 will appear for this flip-flop only. R1 will appear for this flip-flop only. This gets reset because R is equal to 1. Right? Input to this FF0 and this FF2 will remain 0 as G0 is 0 and G2 is 0. Right? Similarly, if we will have to make this FF2 active, I will have to make G2 to be equal to 1, keep G0 and G1 to be 0, and depending upon what is to latch, we will have to change R and S. Right? So, such a flip-flop can be used to make the flip-flop active, that is enable or disable. Gate will decide whether the flip-flop is enable or disable. And so, such a flip-flop is known as gated flip-flop. Fine. Now, in this case, the flip-flop will be active when gate is 0. Gate is 1. Suppose this is my RS flip-flop with a gate, and if I connect a NOT gate and if I convert this flip-flop into this flip-flop. Now one more modification is there. Now this is gated RS flip-flop, right? This is gate input. Here also it is R, G and S. Now let me know what is the difference. If you observe here, when G input was 1, then these two AND gates were active and flip-flop was in working state. It is enable. Whereas if gate is 0, it is disabled. Now what will happen? This GRSFF will be enabled if this G is equal to 1. But to have this G to be 1, this should be 0. Right? So, if the flip-flop is like this, now I can represent this as, I will draw a bubble here. This is R, G and S, Qn and Qn bar. The bubble indicates that it is active low. Check. If it is 0, this is 1 and the flip-flop will be enabled. But if the outermost input, that is if this gate is equal to 1, then this will be 0 and this gate disabled. Right? So if here it is 1, actual input will be 0 and it is disabled. But here it is 0, then the actual input will be 1 and this will be enabled. As a conclusion, if the flip-flop is something like this is R, G, S, Qn and Qn bar. This is known as active high level triggered flip-flop. What it indicates? If gate is high, then the flip-flop is in working condition. It is active high level. It should be 1. Now why it is known as level trigger? You will be realize what is the difference between level trigger and edge trigger later when we discuss the edge trigger. But right now we will not focus on the trigger part. It is active high flip-flop only. And if I draw a circuit something like this, it is representation. Here it is gate R, S, Qn and Qn bar. Then here I will write it is active low. When the flip-flop will be active? If the gate is low, gate is 0. Here when the flip-flop will be active? If the gate is high, it is 1. If it is 1, then it is active. If it is 1, it will be disabled. If it is 0, then actual input will be 1 and this is active, enabled. Right, it is enabled. Right? So this is known as active high flip-flop. This is known as active low flip-flop. Why it is called as level trigger? When we introduce the edge trigger, then you will realize. Correct? Now we shall stop here.